All right, let's go ahead and get started. So you're here for the 5 best practices for building an AWS global transit network. We're joined here from Aviatrix folks. Sherry is the CTO and founder, and Neil's the head of field sales. And as well as we've got a customer to tell their case study. So Jason, who's the director of solutions architect over at Epsilon, is going to join us as well. Nick Matthews, I'm a solutions architect with AWS. And so today we're really going to be talking about sort of networking, transit VPCs, and how that helps your sort of flexibility in the cloud, and what that means from a networking architecture perspective. The cloud is fairly well known by now, but as I've been a network engineer for a while, and one of the things I've seen across both small and large enterprises is your ability to effectively handle and architect and sort of pave the highways for networking is highly influential in how successful your cloud journey will actually be. So whether you want to use things like direct connect, or whether you want to use higher security in AWS or load balancing, there's a number of different things you want to think about here. So from the perspective of transit VPC, there's a couple different reasons why you would want to use that. So transit VPCs allow you to centralize your network connectivity. So in a properly configured VPN manner, every VPC or virtual data center that you create in AWS, if you connect that back on premises over VPN, really considers about 4 different VPN tunnels. So as you might create more VPCs for things like dev, test, prod, or you have mergers and acquisitions, or different segmentation between different security areas of your business, you may choose to have multiple VPCs. And so one of the best things about transit VPC is it can centralize and aggregate that, gives you better visibility and control. And especially, if the people developing things on AWS in the cloud are your developers or lines of businesses, they don't want to be bogged down with, network engineers that might take days or weeks or months to get VPN configuration set up or direct connect configuration set up. It'd be really nice to get sort of one path to the cloud set up, and then whatever you do in the cloud, you don't have to go back and touch your on-premises networking gear again. And that's sort of the whole concept here. If we take a look at how this actually works, the transit VPC is made up of 2 different availability zones. That way it's highly available. We put instances in each one that do VPN. And then in each one of your VPCs, these could be spoke VPCs where application development's going on, or just different parts of your business like shared services or different components. We use VPN either through the virtual private gateway or through other VPN instances to put connectivity and centralized connectivity to the transit VPC. So the transit VPC has the VPN connectivity to all your spoke VPCs through VPN. So all the traffic is encrypted in transit. And then to send it back over to your data center or to the internet or any other sort of centralized place, you can use direct connect, you can use VPN, and you would just extend the tunnels from the transit VPC back on premises. So you create those tunnels back on premises once, and then that gives you central control into all your VPCs inside of AWS. So one of the things we do is, it allows us to connect virtual networks in VPN, so you can use this for remote access. It's all uses BGP and VPN under the hood. So even though this is sort of new cloud networking, it's using well-known protocols like BGP and dead peer detection. And if you don't know what those are, it's not super important, because the idea of the transit VPC is simplifying that and making an abstraction layer that you don't have to care about. And that makes it simpler for you to operate and manage and operate. So it allows you to do things like NAT translations in case you have overlapping CIDR ranges on your VPCs. It also allows you to centralize some security functions like URL filtering. If you need to do any sort of ACLs, it also gives you one sort of place to do that. And if you have a networking team, they find it helpful to have one place to go log in as opposed to having potentially many VPCs to manage. So in terms of use cases, there are a couple different, one is what I've sort of been talking about, is extending your corporate network out to AWS and giving one central point of control. It can also be an easier way to share east-west traffic between VPCs. VPC peering is great. You may find it hard to manage if you get into dozens of VPCs that all have connected intermesh relationships. So transit VPC is an easy way to share that, or even sort of shared services. also our virtual private gateway has a little bit left to be desired in terms of visibility and monitoring. If you're used to logging into a router and, seeing BGP statistics or, getting detailed SNMP or other sort of more detailed network monitoring, we've got CloudWatch metrics, which allow you to know if the tunnel's up and how many bytes go through it. So, Transit VPC sort of extends that and it gives you even more visibility. It also allows you to connect networks between different accounts, between different regions. So if you want to connect to a global transit network, and that's part of what we're here for, you can do that as well. So one of the cool things about this and that we're sort of featuring is the marketplace functionality. So marketplace allows you to go out and test the different transit VPC options. So in this case, Aviatrix is out on marketplace. So you don't need to talk to a salesperson or get a license from anybody. You can go out on marketplace, do a search for the word Aviatrix, and you can test the gateways out. So you can get the controller, you can just deploy this. It doesn't really take much more than, 30 minutes to an hour, depending upon, how good you are at clicking around in GUIs and reading instructions and those kinds of things. But you can test this out, give it a test, give it a try. And if you like it, great. You don't have to turn it off. You can just keep it running. And if you want to do a bake-off, you can turn it off. And again, you're not dealing with any sort of hardware or licenses. If you want to go and get reservations and those kinds of things, you can do that as well if you don't want to pay by the hour. So with this, I'd like to hand off to Neil over at Aviatrix, and he's going to give you a little more details about how their transit VPC works and some of the details.
Thanks, Nick, and good morning, everyone. Welcome to this webinar. So as Nick was saying, you can go to Marketplace and try out Aviatrix. It's very, very simple to do, takes half an hour. But today, my part and my section of this presentation, we're going to talk about a little bit about who we are as a company and our solution and what problems does it solve for you. So at a glance, Aviatrix is a software-defined cloud routing company. We are all network engineers here, and the problem that we are trying to solve or have attempted to solve is that while Amazon has already made compute and storage extremely easy, when it comes to networking, how can we make it similar? A central console for all things networking. And that's the attempt, and that's what you would see in the rest of the presentation. We have software-defined controllers and gateways as a part of our offering, also available via Marketplace. We are Gartner Cool vendor as well, and we are headquarters here in Palo Alto. One other point to note is we are one of the networking companies or founding member of AWS competency or network competency program. So that's a proud moment for us. And you will see the validation of why that is if you experience our product and solutions. So if we look at networking requirement in the cloud, as you all know, cloud engineers who are on the webinar live or those of you who will be watching this later, the networking and the whole entire cloud is not a point in time problem, it's a journey. And in this journey, you would have different problems that you would solve for. In this picture, what you see is there is 4 VPCs, or represented as 1 to n, and in the beginning, the need is just to provide connectivity back to on-prem, and that solution is called Transit VPC. From there, it goes into providing connectivity between each other, which is encrypted peering between those VPCs. Then you also go into giving access to your users. These are SSL VPN access and giving them profile-based access to a part of those VPC or a few VPCs and dynamic enforcement of it. And certainly that comes as very handy. From there, it goes into some of the security requirements because these VPCs, the servers or the systems which are running in these VPCs, they do need access to internet. However, they shouldn't have unfederated access to internet. So limiting your access to egress, having a whitelist both for HTTP, HTTPS, as well as non-HTTP, HTTPS fully qualified domain name, those are additional networking and network security requirement that comes in handy. So as you go through this journey of cloud adoption, there are various challenges that you will face. And what you would find as we are introducing our company is that Aviatrix software-defined controlling routing and controller gateways and controllers will help you through all of these problems. Now, today we are gathered here to talk specifically about transit. So let me go further into the transit. Why do people want global transit architecture? It has become extremely popular. One reason is that AWS talks a lot about it, and so you just heard from Nick, and if you just Google for it, you'll find several articles and blog, many of those from Nick, but also from others who have written about it. So it's a popular architecture, and the reason it is popular is because it solves these three problems. So what is transit? Transit is an alternative to flat architecture. If you don't have transit, you will have flat, and flat means connecting your data center to these VPCs one at a time. So the problem that transit solves is alternative, which is flat, is lack of agility. What does that mean? There is an impedance mismatch. People can create a VPC in all of a minute or less, and networking, if you use the traditional way of doing networking, the flat way, let's say it takes you 2 weeks, then there is an impedance mismatch because your developers want to be creating these VPCs as well as removing these VPCs from your network in a minute or so. And if your network is taking two weeks, then it's not a good fit. So there is a lack of agility in the alternative. It's also not scalable. If you think about the flat way, every time if you build an IPsec tunnel terminating on your on-prem and you have to touch your edge router, obviously it will require a change control window and have to go through a change control process. And imagine a developer building a VPC one evening and asking you to do it. He or she will have to wait for 2 weeks or whatever is your time frame of change. So that means it's not scalable. Those companies which are rapidly adopting AWS or public cloud, they will have this problem front and center. And finally, and in my opinion, most importantly, it's non-cloud engineering friendly. The flat way or the traditional way is non-cloud engineering friendly. And I say that in all sincerity because if you look at the practice across the globe, anyway, the developers or cloud engineers are using a Terraform or a CloudFormation template to build these VPCs. So it might not be Terraform itself, but maybe you have a Python script, but you are using an automation script to build these VPCs, your subnets, your security policies. And therefore, there is an expectation that if I could add 2 more lines to the same script and take care of my networking and network security, that would be the right way. And that's what cloud engineers want. So anytime there is a handoff, there is a manual intervention, there is required for a network engineers to go down there and set things up, all of those are not in the direction of where cloud and cloud engineering is going. So these are the reasons why people didn't like the flat way or the traditional way, and that's why transit got extreme popularity. Lots of people, even when they are small, even when they have few VPCs, they will put together a transit architecture because that's the architecture that will scale for them for the future. So with that in mind, in today's session, we're going to talk about some of the best practices for consideration as you are thinking about building your transit architecture. These considerations are, we have collected them in 3 different slides in 3 different buckets. The first bucket is all around security. Best practices for securing your global transit network. You should think about creating a zero trust model because let's say you have 100 VPC and you connect them back to on-prem, your idea of connectivity should be connectivity by design and not by default, which means you shouldn't be building it in such a way that first you have connected them all and now you're trying to write network ACLs and security rules to stop the connectivity. A prod system should not be talking to dev system. A business unit might not or should not be able to talk to other business unit. These are some of the fundamental principles everybody follows, whether it is in your traditional data center or in public cloud. So a good idea or a best practice is to create a zero trust model where you are connecting these VPCs purely for connectivity back to on-prem and not for just communicating between each other. And then you are selectively declaring using Amazon native peering or otherwise, you're selectively declaring the VPC that need to be connected to each other. So that's the first point. Let's go to the next one. You should have the ability to deploy a stateful firewall as a part of your networking or connectivity solution. What does that mean? Certainly there is the best practices of, a database should not be able to talk to a particular all the application and only a select few of application, and app talking to other app, things like that, which have been which basically translate into source, destination, port, protocol, allow, deny, that type of four tuple rules. So it would be great if your transit architecture and the solution takes into account and give you the facility to define these stateful firewall function. The next security consideration is all about access to internet. Because while transit is primarily about connecting your VPC to each other as well as to on-prem, you are not isolated from a requirement of allowing internet access. Many organizations, in absence of having a good solution, force all of their packet to go back to on-prem and have it pass through a firewall and then go to internet. That is obviously a bad design. It has latency problems, it has a choke point problem, it has a cost problem too. Every time you egress from one VPC to another, you have additional cost that you incur. Wouldn't it be great if you could do distributed execution of your egress control, where the networking system, which is sitting in these VPCs, could allow you to input a set of URLs that you want to allow, and then it enforces them right there. That would come in very handy, and that is another best practice that we are talking about. So that's number 3. And finally, the last one is your ability to export all of these events into your SIEM tool. Anyway, the organizations who are adopting cloud, they have also the data center, and therefore they have a SIEM tool. All of the logs from whether it is your database or your application or your accesses of different kind in your data center or people center are going to this SIEM tool. Wouldn't you want and shouldn't you pay attention to that all of these events, whether they are connectivity events or they are firewall events or they are access to internet events from your cloud, should be forwarded into the same SIEM tool so that you can do a wholesale comparison, be able to do alerting of different kinds and correlation from one to other event and things like that. Now these 4 make the essential security best practice that we are recommending. From here on, we will go into the next set of bucket, which is around best practices for visibility and also monitoring. Now, when it was the world in the data center, all of us had these monitoring and visibilities. In fact, there was an operations team, there was a network operations team, there was a security operations team. So operations team required these monitoring to be there in the first place. But now that it is cloud and there is an architect who is building these connectivities, that architect should be able to pass it to the networking team at some point or to the operations team at some point of time. And that comes in with the visibility as well as with monitoring. And you see this here, whether it is real-time latency, it's a bandwidth or a packet capture, or tunnel status, overtime tunnel performance data, security and audit monitoring from an operation, and alert management. All of that should be the second best practice that we are recommending. You should choose to adopt a solution which can provide these visibility and these monitoring. Will make your life very easy. And then finally, and the last one, is all about operationalization. Now there is this joke that goes around that in the cloud world, whosoever takes on a particular responsibility gets married to that responsibility. And you would hear from Jason LeBaron in next section about some of his experiences. But the idea is that if you pay attention to operationalizing your environment from day one, you would be able to pass this workload to your 24/7 operations team. So what are some of the best practices there? Troubleshooting ability, diagnostic tools of different kind, which can look into both Amazon native peering type of diagnostics as well as the BGP level diagnostics. something where you can basically look at an instance on the left, put an instance on the right, and click on a button and get all the parameters associated with the networking and see where might be a problem. These are simple tools, but they make life extremely easy. So troubleshooting is the first one. Understanding scaling limitation is another factor in the operationalizing. Now, as an architect, you might start with 5 or 10 or 15 VPC, but as you pass it to your operations team, the cloud keeps on growing. Developers keeps on adding, more workload keeps on migrating to the cloud. And therefore, there will be accumulation and growth. And when the growth happens, you will start hitting the scale limit. This could be a throughput scale, this could be route table limit scale, and there are lots of articles written on it if you search for limitations that you might hit as it scales, as the requirement scales into hundreds of environments, hundreds of VPC. So another one of the very important thing to pay attention to. And finally, it's about agility and automation. Traditional routers, a lot of routers are not new. And in data center era, there was a router. And one can argue that you can virtualize that router and put it in the cloud, and now it is your cloud router. But that's not true, because those routers didn't require REST API. There was no need for it. People were doing command line interfaces execution to it. It comes with a hardware which was giving it best performance. That world is very different in the cloud. And therefore, there is need for an agile solution which is fully REST enabled, so that you can do all of these things from your Terraforms, your CloudFormation, or your Python scripts, whichever you choose. These are the collection of best practices that we are recommending here in this webinar. Please pay attention to this. And now to introduce Aviatrix solution, let me bring up Sherry.
Hi, thank you, Neil. I'm Sherry Wei, founder and CTO of Aviatrix. So I'm going to walk you through a little bit about our product. Here you see a picture of the general layout of what we've seen many times in our customer deployment scenario. They have many VPCs, and typically they have a shared service VPCs, and they have transit. And we need to hook them up so that the spoke can talk to transit to on-prem in the most least friction way, and the spoke also need to talk to shared service in the most scalable way. So how do we do that? Aviatrix product gives you a completely different experience rather than logging to each, transit gateway or individual components and configure it. Aviatrix start with the controller. We talked about the controllers in AWS marketplace. And when you launch the controller through CloudFormation, and after that, the controller will gather credentials. We support multiple accounts, so the controller can manage your entire network of different BUs and different accounts. And from the controller, because you set up IAM role, build mutual trust, the controller can launch gateways on behalf of these different accounts, and then you build out product from there. So how do we meet the challenges of the three areas that Neil mentioned about? First of all, let's talk about security. How do we implement a zero trust or more network segmentation in our transit? We call next-gen transit architecture. In Aviatrix case, solution case, the spoke gateway cannot talk to another spoke unless you instruct it so. So it is what we call connectivity by design, not by default. It's not by default you have a full mesh and then you use security policies, try to isolate. Managing that of hundreds of gateways is very difficult. So we have segmentation by default, so that's security. And we talked about each gateway in the spoke gateway also has an egress function so that it's multitasking. You can also take care of whitelisting to your internet access. The whole philosophy is that it's centrally managed. Even the data streams are fully distributed, meaning that the traffic only go through transit hub to reach on-prem. The traffic from spoke to spoke is direct connection. either over AWS peering or over Aviatrix peering, or to share service. And the traffic to egress to internet, it's also go down distributed by the gateways. So there isn't a single performance bottleneck in the entire system, and it's fully distributed. So I digress a little bit. We're talking about security, and we also have out-of-box integration with event log systems like Splunk, Sumo, and Datadog, and ELK, and Syslog, so that gateways are distributed export events to these log services that you already subscribe. Then the second is, how do we meet the visibility challenge? Visibility really has a few parameters in there. One is real-time latency. How is my network doing? So we constantly display and show your latency between hops and between spoke to transit and transit to on-prem. So the latency, and then throughput visibility. You want to know what is the throughput and going in and out of a gateway. We have that, and then you also want to have the ability to monitor tunnel status and down, and that monitoring can be triggered to your either an email alert, or that can be integrated into your Ops Genie or PagerDuty, so that you can have further processing. It's out-of-box integration, so that you can further processing about off hour, on hour, and who should be getting the pager, and so that is in the visibility domain. And then the third one is operation. Obviously, operation, you have to think about build for simplicity. And one of the things we build is we have for the transit build out, we have a workflow like wizard, step-by-step guide you through, so you know what you're doing. It's very simple point and click. We also have complete Terraform and build for simplicity and build for automation. We also have Terraform and REST API. One other thing I want to mention about build for simplicity is our architecture is very different. The BGP is only run between transit gateway, Aviatrix transit gateway to VGW. Everything else, the rest of the network in the cloud, is all software defined. And that software defined not only allow us to simplify the build out, but significantly also simplify for troubleshooting. So you're not tracing hop by hop, you're not managing hundreds of BGP sessions, and that basically makes even the CCIE extremely difficult to maintain and troubleshoot for operation wise. And also you have to consider build for scale. Build for scale come from two areas. One is AWS itself has route limit and has security group limit. You have to overcome that. And also build for scale also means that you need to think about they will scale to potential hundreds or thousands of gateways, because your network will grow because of accounts, because of VPC clients, different reasons. And you have giving a centrally managed controller and be able to centrally manage these hundreds of gateways is a challenge that you need to think about, that your solution needs to build for scale. So that covers the operation side. So I have gone through the three areas. So in summary, Aviatrix solution brings simplicity to the transit through our central controller, and we have built-in security and encryption. We believe in network isolation. We do not allow literal movement like you would do best practice for your data center, and it's software defined. We have visibility, monitoring, and logging built-in for out of box, and REST API for automation. And these compared to your traditional vendor solutions, it will give you a very different experience.
So with that, let us introduce Jason LeBaron. Jason, take it over.
Great. Thanks, Neil. Thanks, Sherry. My name's Jason LeBaron. I've been with Epsilon about 5 years now. I have a strong background in all things network, security, and cloud. I lead up the solutions and cloud architecture within our organization. I'll go ahead and tell you a little bit about Epsilon, who we are, kind of the business that we're in. We're a global marketing company. For more than 4 decades, we've been helping brands improve their marketing and build better customer relationships in retaining and finding new customers. Epsilon was recently recognized again by Forrester as a leader in email marketing service providers. We help our clients connect with consumers at the right time and place, both online and offline, creating emotional connections to the brands in everyday life. Our business is data-driven with a highly personalized and creative experience output built on world-class technology where we continually measure and optimize the experience. Our business continues to evolve using cloud technology services as the underlay to create faster, more scalable, feature-rich services across our brand loyalty service offerings. We optimize that experience with engagements with the end consumers, providing cross-channel orchestration and personalization. Talk about some of the challenges that Epsilon's experienced as we've adopted cloud. The scale at which we deliver these services at this point spans many regions and hundreds of VPCs. Foundational to the trust that we maintain with our clients is ensuring that we use security every layer. Security really is everyone's job at this point. Use that to protect the data and services within and between cross-functional platforms. We have the challenge of dynamic business and compliance requirements that are continuing to adopt and change over time. And then we have providing transport within the cloud and to our on-prem resources for various workload types. Requirements, as we started to engage down this path with AWS and Aviatrix, our top 5 requirements, this had to have an API-driven solution to meet our end-to-end automation. That allows us both to scale quickly to the business as well as prevent errors along the way. We prefer to have single pane of glass management where we can that provide insight to the health and allows for continuous optimization of the services. We needed to look for partners that could help us avoid preventing legacy IP overlap conditions or degraded conditions. Again, this is about getting in front of problems before they occur. Like Sherry and Neil have mentioned, we have a desire to free up traditional network resources to focus on core business challenges. And then we needed a flexible architecture so that we could continue to meet the dynamic nature of our business and compliance requirements. Epsilon solution on Aviatrix, we use a number of the components that Neil and Sherry have already outlined. One of the core building blocks is the transit hub for providing secure transport routing from AWS to our on-prem workloads. This allows us to tap into cross-platform client services. The solution for Epsilon is automated using the Aviatrix controller and the API sets, allowing us to deploy a predictable, secure pattern that avoids errors. We also use encrypted pairings between VPCs. This could be for shared services. This could be for other cross-platform needs that are within the cloud. And again, this leverages encrypted pairings, allows us to meet common compliance and business regulations along the way. The result for Epsilon, this has facilitated the growth of our requirements across more than hundreds of VPCs across different regions. We've been proactive capability to reduce or eliminate performance bottlenecks. We've automated the secure onboarding of client accounts and services quickly. We have increased visibility throughout the entire network. We've made major changes in reducing manual processes through automation so that we can onboard quickly and avoid errors. We've increased the use of resources to focus on core business challenges, not legacy networking constructs like complex BGP routing. The Aviatrix transport overlay services provide the secure plumbing that deliver the optimized customer experience for our clients and their consumers when engaging with one of our loyalty-based platforms. And with that, I'll turn it back to our presenter for Q&A.
All right, cool. That's a cool story there. So folks that are out there, we haven't seen many questions come in here. So if you have any questions about transit VPC, how that works, or how security might work, or how routing might work with a transit gateway, we can sort of go through that. All right, so questions in here. So one of the questions is, what high availability scenarios are supported by Aviatrix for the transit VPC? Sherry or Neil, you want to take that one?
Yeah, let me answer that. So it is highly available. The transit, the gateways and the transit is active. So they, in a way, the load balance should a spoke fail. So one of the criteria is when the spoke to transit tunnel fail, you should not have ripple effects affecting other spokes. So they will be fell over to the transit backup. Therefore, that link is going through a different path. So it is highly available both for transit as well as spoke. You can have backup gateways.
Sure. There was one question here that says, can you talk about some of the throughput that your transit VPC can support?
Yes, so that is a very good question. Today, the throughput transit gateway is limited to about 1.25 gig. Some people say 1.5 gig. That has so that is actually the entire transit network throughput and limit, and that is also an industry benchmark. It is limited on VGW performance because there is if you look at our diagram, there is a BGP session to a VGW as an IPsec, and VGW has that limitation. Aviatrix Gateway has that limitation. Everybody else has that. But we are very excited to let our audience know that in the next coming release, we have we call insane mode encryption, where we would overcome this limitation of performance, and we can get to 10 gig with the encrypted with the transit solution. In fact, we have shown that in our current development that spoke to spoke, we can achieve 20 gig IPsec performance. And the transit overall, we are shooting for, we're seeing the 10 gig. And we can talk in details where the bottleneck is. We can talk in infinite depth of what it is. And we're working with the AWS to see if we can remove some of the performance bottleneck.
Cool. And then Jason, looks like a question for Epsilon. Did you guys use that for cross-region routing at all, or use Aviatrix between two regions? Is that something you looked at?
Yeah, we are using some of that for cross-region where it's needed and required. We don't have a whole lot of that today, but there are a few corner use cases where we are using the Aviatrix solution between regions.
Sure. There was another question here that said, when do customers use Direct Connect versus Transit VPC? How do you help customers make that decision?
Yeah, great. I can take that. So Transit VPC or Direct Connect it will have to go into detail, but at a high level, people use Direct Connect to do the hop from the data center all the way to the Transit VPC, and from there using Aviatrix, which will exchange the BGP route back to on-prem to connect to all the VPC.
Yeah, and I'll add to that, sometimes if you have some very, very high bandwidth functionalities like, I don't know, high performance computing or data lakes or something like that, particularly S3, sometimes it's better to say, hey, just for this one VPC or this one environment, let's connect that through Direct Connect. I've seen that where, people have maybe performance concerns or things like that. Sometimes there's just one ops where Direct Connect is faster. So let's see here. This is a good question. So is Transit VPC a single point of failure? What do you guys want to take that? Otherwise, I can give a shot at it too.
Yeah, so it's a good question. That's why we try to limit to that. So there is a balance. In our architecture design, we have mentioned that we try to distribute the traffic streams as much as we can. For example, we separate traffic between VPCs. They don't go through transit, unlike the traditional transit hub solution where everything goes through the transit hub, right? So at least VPC to VPC, they don't go through transit. VPC to share service, they don't go to transit. VPC to internet, they don't go through transit. So the only traffic that the transit carries is the spoke VPC to on-prem. Now, this is the balance now, is yes, it is if you have absolutely no single point of choke point, performance point, then you would want to have every VPC connected to on-prem directly. Like Nick mentioned, you need high performance today. There isn't. If you need to be on 1 gig, you probably need to put that VPC for a VIF direct connect to your on-prem. But the balance here is by doing that, if you have to do that for hundreds or even 10, that means you need to set up a separate BGP session to on-prem. You either going over internet doing IPsec or you're doing direct another BGP. I do not think the real data center engineers, network engineers, even CCIEs have, wanted to manage large numbers of BGP sessions and neighbors and troubleshoot that. Because even on-prem, you hand it off to MPLS, you are basically a CE router, and MPLS ISPs, AT&T, Verizon of the world are doing all the complex routing. So it is a balance. So that's why the transit gateway we have, we made it a pair, a multi-AZ-HA. So it's a balance between agility, speed, and also the performance bottleneck. So you kind of need to understand that balance. Yeah.
So here's one for Jason and Epsilon. So you mentioned 100 VPCs, and if you have multiple accounts, do you see the transit solution deployed in sort of a network services account, or maybe you can talk about any challenges with onboarding accounts with your solution?
Yeah, where we've used Transit Hub, we sort of put it in an elevated privileges type of account, just to ensure that we have security and separation and can apply some different controls as traffic perhaps transits back through there to reach some common services.
Okay, cool. So one of the questions here is, does this support cross-account connections? So, the answer to that is yes, because it all uses VPN, and VPN doesn't care where you are. So, you can do this across accounts, across regions. It's not a problem. If you decide to use AWS's VPC peering, our VPC peering is also encrypted cross-region. So, if you find it easier to use VPN as opposed to peering, you can do that. Otherwise, you can do it either way, really. Same thing with cross-account. So there's another question here about cross-account. So yeah, VPN goes cross-account, no problems there. There's a couple of questions here. Sherry and Neil, if you want to answer this, they sort of curious what your competitive differentiation is.
Right. So let me take on that. We have a lot of content on our website about specifically competing with traditional router-based solutions. In fact, I think Jason, before he met us, he was on one of those solutions. And you will have a significant different experience. We start with the controls. There's a central panel, as I said, 3 areas to consider: security, some operation, and visibility. And we can go through each of the areas. You can think about when you compare them, how Aviatrix does and how the traditional router-based solution works. Jason, could you help also answer this question?
Yeah, absolutely. We've experienced traditional networking solutions, obviously on-prem as well as in the cloud, and like others have experienced headaches kind of along the way of some of those legacy solutions that are single constructs, single visibility, not really optimized for cloud workloads. Just the engagement with us and Aviatrix has completely changed the way that we lay in transport services within the cloud and to our physical data centers. Been a very responsive team in addressing business challenges and additional desired functionality. So.
Cool. And then there was another question here about when you deploy the transit VPC, where's the controller? Is it its own VPC or is it in the transit VPC? Where do you guys usually deploy that?
Yeah, good question. Typically in the cloud best practice, even AWS recommend there's a shared service. You can deploy it there. There isn't real constrained about where that thing sits, the controller sits. But we've seen most of the time our customer deploy them in the shared service VPC, and it is very rare to deploy in the transit VPC, because transit is really a hub where you just want to move traffic in and out. It's not even optimal to put instance there, but there are cases people do that. We've seen those patterns, but typically it's in the shared service. I don't know, Jason, where did you guys deploy the controller?
Yeah, we've got our controller kind of sitting outside in another elevated security account that is separate from the transit. Again, to your point, Sherry, it really can land anywhere, but there are some best practice patterns to consider.
Cool. So there's another question here that asks, does the Aviatrix controller automatically find new VPCs and connect them, and how do new VPCs sort of work in this workflow?
Right. So the key is you notice that there was an account concept. The account really corresponds to your AWS IAM role and credentials. So we can, since we support multi-accounts, and you can put account credentials there, and that really is to build trust and the policies relationship to the controller's account when you launch the controller from the marketplace, and the IAM roles and policies are pre-built. And it builds a cross-trust relationship to that. And from there, the controller can launch gateway in anybody's, that account, in any VPC, any region, and on behalf of that account. That's why it gives you a central panel. From there, you can manage multi-accounts and launch gateways and build connectivities.
Sure. And there's also a couple questions here about using the trans VPC. Let's see here. I lost the question. About with overlapping CIDR ranges. So, what happens if developers go nuts and start using the same address ranges? Are there any best practices about sort of keeping them on the rails, or what do you guys usually think of the solution for that?
Right. So we have a couple of ways. We actually just released a feature called VPC Tracker, and it doesn't require gateways. As long as you input your secondary accounts, it will have single page list all your CIDR blocks and belong to which accounts and stuff like that. So hopefully when you have a new VPC, you can check against if there is overlap. And so that's one thing that's preventive. So give you a little planning tool so that you can check against, because sometimes there's so many accounts you may not know who's doing what, even though you use spreadsheet to allocate, but not everybody follow that. So that's one way to do. Second is we support overlapping IP CIDR block. It's a simple network mapping. It's one-to-one mapping to facilitate VPC to VPC connectivity when they have overlapping addresses.
Sure. So this one's for Epsilon. It says the design shows internet access through a retail location, but I thought Jason, you were speaking about having spoke VPCs go to transit VPC through the edge. I'm not sure if that makes sense to you.
Obviously, we do have to provide internet services in our containers that deliver services to our end clients. I guess I'm not sure I completely follow the question there.
Okay. Yeah, I'm not quite sure either. So we'll move on, I suppose, here. So let's see here. Do you want to talk about the cost model a little bit here in terms of the data transfer costs and how that sort of works?
Yeah, sure. So at a high level, this is a marketplace solution, and it is charged by the hour. It's 16 cents for a tunnel. A simple way of imagining this is if you have 10 VPC and you're trying to build transit, you as a customer would be paying $1.60 per hour to have your entire transit built. Additional functionality from Aviatrix, like you saw from our monitoring, our overall visibility, troubleshooting, those are all included in it, and there is no separate charge.
Okay. And here's another one: is what's the disaster recovery design look like for this? How would you guys recover or back this up?
Yes. So one thing to note is controller is not in the data path. So controller is the brain, is the setup, all the things. The worker bees are all the gateways. But if controller goes down, the network data path is still flowing, packet is still flowing. However, we do have controller. We have HA that use AWS auto scaling and Lambda functions, and we also have backup and restore. So you can the entire configuration can be backed up to S3. So you can always launch. You can manually, or you can use our HA function to bring up the backup controller. So that is for the controller. For the gateways, obviously, it cannot be disaster recovered to a different, today it doesn't do to different region. However, it's multi-AZ in the same VPC.
Okay, cool. There's also a couple questions here in terms of how BGP works in this scenario. So maybe you can talk a little bit about how BGP works in the transit VPC for this.
Sure. Okay, so we really take a different approach. You know, traditionally, as a network engineer, you want to run BGPs. What we have done is the BGP is limited between VGW and the transit gateway, and so it's necessary because we do not want to rip and replace also in order to talk to on-prem. And also VGW, if you run direct connected, you can only terminate BGP. So all the on-prem traffic, feeder blocks needs to talk to our transit gateway in order to exchange routes. So then the transit gateway will actually send the information to the controller, and the controller propagates in a software-defined fashion to the spoke gateways. That's why the spoke gateways, there's no BGP running, and we limited that. So you only have your entire transit network only has 1 or 2 BGP sessions in the transit limited. And the rest of them, because it's software defined, it's much simpler for troubleshooting. You do not need to understand or do not need to know, is the route propagated or is the route being dropped or which BGP session along the path to understand that. So that's our philosophy. That's why we say BGP is limited in the transit, and we need to do that in order to interoperate with the legacy on-prem network. We have mechanisms to overcome, not overcome, to scale. Part of the architecture is the controller, when they send message to gateways, it doesn't send directly. Otherwise, it would be hugely complex to solve, the retransmission, the queued up, and all of that. We actually leverage AWS SQS. So we send it to SQS, knowing that it will be delivering order. It will always be there, highly available. So, and it totally decoupled the controller and the gateway. So our architecture is centrally managed, loosely coupled a system that is highly scalable, allow us to scale and make the controller much simpler.
Okay, cool. There's a question here also on the pricing models. What are the pricing models you guys are using here?
Yeah. So once again, on pricing model, it is also all from AWS Marketplace, and it is in an hourly fashion. Aviatrix tunnels cost 16 cents per hour per tunnel. If you have 10 VPC and you're trying to build transit, it would cost you $1.60 to put the entire thing in place per hour. $1.60 per hour to have 10 VPCs be architect in a transit design.
All right, cool. Let's see here. Another question is there any relation here to AWS organizations?
Which organization?
Yeah, the AWS organizations. So, I mean, from what I understand, I think AWS organizations probably, you could probably do some things with CloudFormation template and the service policies to tie this in with integrations, but as far as I know, there's not any sort of native integration with AWS organizations.
Yes, on the business side, we're AWS technology partners, and we are the competency partners. On the technology side, we use everything we can on the AWS native service. Like I mentioned, we use SQS, we use the AWS APIs extensively, we use AWS S3, we use Route 53, we use load balancers. We use everything we can to make our system scale and make our system do less work and leveraging the service that AWS already offer.
So one question is IPv6. Is there any IPv6 support on this?
IPv6 is on the roadmap. We have not heard a lot of requirement from a customer. We are a company, a startup company. We are extremely customer focused or obsessed. So if you have such requirement, reach out to us and let's discuss. And we understand the business opportunity, market opportunity. We will pursue it.
Cool. Well, I think we're wrapping up here, folks. Do you have any other sort of questions that, or any sort of parting thoughts or call to action or anything you guys want to put out there?
I would encourage everybody to go to aviatrix.com/trial. It just takes 15 minutes to get started with it. And lots of questions that you asked can be experienced yourself. Like they say, proof is in the pudding. You can enjoy the pudding all in 15 minutes in your own comfort. One of the things that Nick mentioned before, this is a very cloud-like solution, and we behave like an AWS organization. You don't have to talk to a salesperson. You can go to it. Most of our engineers are on Drift on our website, chatting with you, answering your questions. You'll have a great experience if you give it a shot.
Cool. Well, Sherry, Neil, Jason, thanks for joining. I think this went pretty well. And thanks everyone for joining. And see you next time.